We're going to now get into data visualization. And so the way we're going to do that is we're going to start off with univariate plots, which is just basically looking at each individual variable. And then we'll get into multivariate plots to better understand the relationships between different attributes. So what I'm going to do, we are going to import pandas, and we're going to have pandas tools plotting. And it's going to be an import for scatter matrix. And we also are going to need an import matplotlib.py plot as plt. And just to put a comment here, so that's going to be used to plot our data and show the results graphically. All right, so I've got our iris data here. I've got the Pima Indians data here. I've got the names as well. So we are going to start with loading this data. So we'll have our data object and start the load process. So CSV URL names equals names. And then we're going to data plot. So what we're going to do here, again, we're starting with univariate, and we're going to basically take the variables that we have, which are numeric variables, and we're going to create a box of Whisker plots for each. So if you haven't seen Whisker plots, you're about to see them. All right, so the kind we're going to do is box. So we have a few name parameters that we are filling in here. And subplots with an S is going to be true. Let's see, we want our equal sign here. And after subplots, we're going to have layout. It's going to be 3 by 3. And comma, share X is going to be false. And finally, share Y is going to be false. So to comment on what this is doing, we are drawing data here, and additionally it will not draw visually. Basically what that means is it will instead create the data for plotting and drawing. So we basically initialize out what it is we want to represent visually. Then we need a way to actually represent it. That's what's going on. And let me do another comment here just to explain some of these parameters. So this is going to be a 3 by 3 layout because we have 9 variables to draw. All right. We're going to access our PLT, which is the PyPlot alias, and do a show. Now this is going to run a little bit different. We've been seeing how a lot of this can be run in an integrated terminal, which we can run here, but the actual output is not going to display in the integrated terminal. So I'm going to do my Python module 4.py. So to get the visual output, it's actually going to call into Python. So if I run it, you'll see, there we are. And you can see here, this is coming out of Python. So these are our various charts. So again, everything here, it's all the different, you can see here, the columns that we have are being represented, and there's the name of the column right above each of these. This is pretty small, so if you make it bigger, everything's not going to squash together quite as much. And to end this, I'm going to go down here to put this Python icon and quit. And it returns me back to my command prompt in the shell. So I'm just going to move this down a little bit, and we're going to keep going forward with some of our others. So next what we're going to do is a histogram. And for that, we are simply just going to call this function hist. So going back to what we did here with this plot, we've basically initialize the drawings, and now we just need to call functions to output the various kinds of drawings. So from here on, it's not really a lot of work at all. And after you call one of these functions, you want to call show. I could comment this show out because you only want to do one and put it down here like this. So if this one was still here, I'd want to comment it out because this one's going to show, not this one. It's going to just run one at a time, basically. I'll just leave that there and run this one now. And just wait for that. There it is. So notice down here in the shell, we have it returned because this right here is kind of taking it. And again, I've got a pretty small resolution. So if I spread this out, you can start seeing how this all looks. And if we look at these, we can see, let's see, we have mass, is this PLAS one here. We have down here PRES. It looks like a few of these have a Gaussian distribution, right? They have that bell curve. If we going through this and we see that, then that gives us some ideas about algorithms we might want to use. So you may want to then take some algorithms that can exploit your assumption that some of these are using a Gaussian distribution. And maybe these two here, mass and PILS, I think that's what that is. Let's see what the names are. Get that one out of there. It's actually, yeah, PLAS. Are better Gaussian distributions than probably this one down here, PRES. All right, so I'm going to go ahead and stop these, and we'll go to the next one, and which are going to be multivariate plots. So now we're going to get into looking at the intersection between variables. So we're going to look at the scatter plots of all pairs of the attributes, which it can be helpful because you can spot different kinds of relationships between input variables. So going on from here, that is going to be scatter matrix. We're going to pass in data, PLT show. And I'm just going to show the one, so I'm going to comment this out. And I am going to do multivariate plots, just to make it clear. And we can run. So that should draw, and once it's finished, it should come up in another window. There it is. Let's see. Okay, so the other one's kind of lingering around, I believe. Yeah. Just going to move this one and this one. And this one here is kind of squashed a bit, again, because of resolution, but make it bigger, you can start seeing a few things in it. And if we look at this, these distributions almost look again like Gaussian. Some of them do. Some are skewed, but going diagonally all the way across, we got basically this diagonal grouping on some pairs of attributes. And really what it's suggesting is that there's a high correlation and a predictable relationship. So again, we have these assumptions from this visualization that can lead us down the path of choosing some appropriate algorithms when we start doing more heavy analysis on this data. So that is plotting. We've done a number of two-dimensional plots in this particular exercise. So, and we've also kind of discussed a little bit about how you may do some observations of your data to help you figure out what kind of algorithms you might want to use to further or do further analysis on this data.